Hello, class! Electronic products have become ubiquitous in various aspects of our lives. To use them more effectively, we need to enhance our awareness of electrical safety. Today, let's learn about electrical protection knowledge. The insulation materials of various electrical devices are mostly flammable substances. During the operation of electrical equipment, conductors generate heat when carrying current. When a switch interrupts the current, arcing occurs, and short circuits, grounding faults, or equipment damage can also result in arcs and sparks. All of these events may ignite surrounding flammable materials, leading to fires or explosions. Protection against electrical fires. 1. According to the requirements of different environments, correctly select and install electrical circuits, equipment, and protective devices. 2. Strengthen daily maintenance, inspection, and repairs. Regularly check electrical circuits, equipment, and insulation materials to test their insulation and withstand voltage. Promptly address any issues to keep the circuits and equipment in good condition. 3. Prohibit the unauthorized addition of equipment to prevent overloading. 4. For devices and equipment prone to static electricity, take appropriate measures to eliminate static electricity separately. 2. Extinguishing electrical fires. 1. To prevent the spread of fire and the occurrence of electric shock during firefighting, in the event of an electrical fire, the power supply should be immediately cut off. In the case of a transformer or oil switch catching fire, there is a possibility of explosion and oil spray. It is preferable to extinguish the fire after disconnecting the power supply. 2. Due to the inability to halt production or other reasons, it is necessary to fight the fire while the power is still on. Appropriate firefighting equipment and devices, such as carbon dioxide fire extinguishers and dry powder fire extinguishers, should be selected. During firefighting, firefighters must wear insulated shoes and insulated gloves. 3. When using non-conductive extinguishing agents at a voltage of 10 kV, the shortest distance from the nozzle of the fire extinguisher to the charged body should not be less than 0.4 meter at a voltage of 35 kV. This distance from the nozzle of the fire extinguisher to the charged body should not be less than 0.6 meter. If a regular water cannon is used for firefighting for voltages at or above 110 kV, the distance between the nozzle and the charged body must be maintained at 3 meter or more, and for voltages at or above 220 kV at 5 meter or more. Electrical explosion proof measures. In places where flammable and explosive gases and dust are present, we should correctly select and install electrical circuits and explosion-proof electrical equipment. And the workplace should be well ventilated. Explosion-proof equipment should be used in explosive atmospheres such as explosion-proof motors, etc. The safety of using portable electrical equipment on site should be paid much more attention. The power supply should adopt a 3-phase, 5-wire system or a single-phase, 3-wire system, and connections in the circuit should be made by fusion welding or soldering. Automatic power-off protection devices should be installed to ensure proper operation. The powerful currents, high voltages, and elevated temperatures generated by lightning can cause significant damage and have various destructive effects, leading to severe disasters in power systems and posing a threat to human safety. The formation and patterns of lightning. Thunder and lightning are intense discharge phenomena in the Earth's atmosphere. During the formation of thunderclouds, due to factors such as friction and freezing, there are a large amount of positive or negative charges resulting in high electric potential. When thunderclouds with opposite charges approach a certain distance, the air is pierced, leading to a powerful discharge. Types and hazards of lightning. Direct lightning flash. When thunderclouds are relatively low, static electricity is induced on elevated objects on the ground. The induced charges discharge in the opposite direction to the charges carried by the thundercloud, resulting in a voltage that can reach several million volts. Inductive lightning. The overall voltage produced by induced lightning can reach several hundred thousand volts. Ball lightning. During a lightning strike, a fireball that emits red or white light is formed. Lightning intruding waves. During a lightning strike, power lines or metal pipelines will generate high-pressure shock waves. The damage and hazards of lightning primarily manifest in the destruction of electromagnetic properties, mechanical properties, thermal properties, and the breakdown of step voltages. Common lightning protection devices. Lightning protection involves directing lightning currents into the ground to prevent damage from lightning strikes. Common lightning protection devices include lightning rods, lightning protection wires, lightning protection nets, lightning belts, and lightning arresters. Lightning rod. A pointed metal conductor installed on tall, protruding, isolated buildings or outdoor power facilities. It utilizes the principle of sharp discharge to accumulate induced charges from thunderclouds at the top of the lightning rod. It continuously discharges these charges to the approaching thundercloud, achieving the neutralization of ground charges and thundercloud charges. The protection range of a single lightning rod is a broken line cone from space to the ground. Lightning protection wire, lightning protection net, and lightning belt. These operate on the same principle as lightning rods. Lightning protection wires are mainly used for lightning protection in power lines, while lightning protection nets and lightning belts are primarily used for the protection of industrial and civilian buildings. Lightning arrestor. There are three types: protective gap, tubular lightning arrestor, and valve-type lightning arrestor, with similar basic principles. During normal conditions, the lightning arrestor is in an open circuit state. When lightning overvoltage occurs, breakdown discharge happens, directing the overvoltage to the ground. After the overvoltage is terminated, it quickly returns to the blocking state. Among the three types of lightning arresters, the protective gap is the simplest, with lower performance. Tubular lightning arresters offer slightly better protection and are mainly used for weak points in insulation in incoming lines or circuits in substations. Industrial distribution devices often are equipped with valve-type lightning arresters that are typically installed at the entrance points of circuits. Common knowledge of lightning protection. To prevent induced lightning and lightning intruding waves from entering indoor areas along overhead lines, the insulator iron feet on the last support structure of the entrance line should be reliably grounded. During thunderstorms, it is advisable to close doors and windows to prevent ball lightning from entering. Avoid standing in front of windows, on balconies, or in front of chimneys. During thunderstorms, it is best to avoid bathing or washing hair and avoid staying in damp places indoors. During thunderstorms, it is advisable not to use household appliances, and the power plugs of appliances should be unplugged. During thunderstorms, avoid staying on hilltops, lakesides, riverbanks, swimming pools, and other places prone to lightning strikes. It is better not to use umbrellas with metal handles. During thunderstorms, do not stand under isolated large trees, utility poles, and tall walls. Avoid riding in open vehicle and bicycles when seeking shelter from the rain. Choosing buildings or objects with shielding effects. Considering the above knowledge, let's think about how to extinguish an electric fire and what are the common lightning protection devices. More knowledge will be discussed next time.